Discovery in science is generally a story of small steps, each one bringing a little more understanding, but none of them giving the full picture. The beauty of science is in the journey. Let's go on the journey of the discovery of the atom. This is Real Chem. The journey towards modern atomic theory involved a lot of experiments over the last 200 years or so. In between every step of discovery lies 1,000 experiments. This journey, including both what we recognize now as breakthroughs and what might seem like failures, is actually how science works. Vamos a mirar juntos. It was initially thought that elements were composed of tiny, indivisible particles called atoms. This model envisioned atoms as solid spheres, with each element having its own characteristic mass. There was no sense of what might lie within the atom. For that, we waited until the very end of the 19th century. The cathode ray experiment in the late 19th century revolutionized the understanding of the atomic structure. By passing electric currents through evacuated tubes, it was determined that cathode rays consisted of negatively charged particles. We now know these negatively charged particles as electrons. This discovery led to the plum pudding model, where electrons were embedded in a positively charged sphere, similar to raisins in old-fashioned baked pudding. Therefore, the spheres now had an internal structure. 15 years later, the charge of a single electron was determined by measuring the forces acting on oil droplets suspended in an electric field. Remarkably, all the drops had charges that were simple multitudes of a single fundamental value, the elementary electric charge of an electron. We could now see the quantized nature of electric charge, giving us crucial evidence for the existence of electrons as discrete entities in matter. About the same time, experiments were taking place where alpha particles, which are positively charged, were bombarded onto a thin gold foil. Most alpha particles pass through the foil, as we might expect from a plum pudding model, but very occasionally, some were deflected. From these patterns of trajectory and deflection, we were able to deduce that atoms were overwhelmingly empty space. But they must also have tiny positively charged nucleus at their center. This gave rise to the idea that the nucleus contains positively charged particles that we now call the proton, and essentially meant that the plum pudding model was no longer valid. Many years later, scientists realized that the mass of the atom could not just be due to the presence of electrons and protons. Further experiments revealed the presence of neutrons, neutral particles with the same mass of a proton. Neutrons reside in the nucleus, giving the nucleus extra mass, but not extra charge. These and other experiments collectively painted a picture of an atom where electrons orbit a central nucleus, much like planets orbiting the sun. We now know these lovely centered planetary circles are an oversimplification of the actual behavior of electrons, and the orbits have been replaced with the shells of the shell model of the atom. Science continues to move forward, and thus our understanding continues to evolve. Science embraces the unknown, accepting that we are never at the end of the road to discovery, but simply that the road continues into the distance as we learn more and more. Our journey as learners is no different. Tiny steps, small breakthroughs, but one awesome adventure. Vamos a explorar y no se te olvida tener fun. So explore and remember to have fun.